the second part of this section, and here we are going to consider line integral of a vector field. Let's say we have a curve, parametric curve given by c of t. Now we have a vector field on this curve. So maybe at this point I have a vector like that. Maybe here your vector is this. Maybe here your vector points in this direction, and so on. Okay. But let's say in general, this is your c of t. This is your c of t. It's a vector function. And this is your f of t. This is your vector field f at c of t. So I will write it like this. Okay, now we define the line integral of a vector field. Let's consider a vector field in three-dimensional space. So basically our vector field f contains three components, f1, f2 and f3, and each of these function is a function of x, y and z, and we have a curve c of t which is given by this parameterization x of t, y of t and c of t on the interval a comma b. So basically your t goes from a to b. Then the line integral of the vector field f over the curve c, now we write dot product and dot product with ds. Now here this line element is a vector quantity, and we can take the dot product of two vector quantities, so f dot ds, and this equals to line integral from a to b of the vector field at c of t dot c prime t dt. Let me write it like this. So basically this notation means we have to evaluate our vector field on this curve, and then we should take the dot product between this vector field f and c prime of t. Again, let's make a note, this should be the dot product. Okay, now this is the way we define the line integral of a vector field, and in the next video I will prove this result. But before that, let's consider a simple example.